So the question here then, for this section, we're talking about area under the curve. And actually, this question says, what's the area between y equals negative sine x curve and the x-axis? So let's just quickly draw here a rough sketch of negative sine x. Okay, so it starts down here, goes down to negative 1, comes up, and I'm going to add here, okay, between negative pi and pi, so on this interval. So if this was pi, negative pi is going to be symmetrical, if I can do it. Okay, from there to there. That's not quite symmetrical, but you get the picture. Should I try and fix that? Maybe I should try and fix that. Okay, let's try and fix that. Let me do this first. Okay, a little bit better. Negative pi. Okay. So, what's the area? Now, if you recall what we just talked about, any area under the curve, which is given here, so this is y equals negative sine x, the area under the curve and above the x-axis will be positive. Okay, we're going to have a positive area when we do this. The antiderivative evaluated at the right boundary, which we always said was b, minus the antiderivative evaluated at the left boundary. So for this area, if this was b and this was a, we would get a positive value, right? If we did the same thing over here and we said this was b and this was a, right boundary, left boundary, this under here is going to be what? It's going to be, you're going to get a negative value when we do this. So here, f of b minus capital F of a is going to equal the negative area. So we're going to get the right value, but it's just going to show up as negative. And the example that I used before, right, was if you have a large area and you want to subtract, you want to find the area, for example, is this large area minus this area. So the example I used was, this is my desk, and this is the classroom, and what's the area of the classroom, not including the area of my desk? Well, if you did classroom minus desk, you would get the area of that which remains. But if you did desk minus classroom, you would get the same number, but it would be negative, right? So think about that when you're doing this example. And there's two parts to this example now. So I'm going to erase this here now. And if you go ahead and do, let's say we want to make this the right boundary and this the left boundary. Well, that makes a lot of sense because this is the furthest right, this is the furthest left. So knowing this and knowing what we know about negative sign, we're going to have a positive number and the negative of the same number. And so we had mentioned before that we think that we might not get the area we're looking for. That's this plus this. So let's just see. So the antiderivative of negative sine x is what? Is positive cos x. Very good. And so let's do cos of pi minus cos of negative pi. Let's just test this out. So here's b, here's a. Let's find out what we get. Cos of pi, if you remember your unit circle, negative 1, 0 is this coordinate right here. So cos is the first number. So we have negative 1. If we subtract the value from negative pi, and that negative pi would be going this way around, that should be the same value. So we get negative 1 minus a negative 1, which is 0. So you see how it looks like there's a 0 area between the curve and the x-axis? We know that's not true, but that's because this is going to show up positive, this is going to show up negative. So there's a couple ways you could approach this. What you could do is you understand that sine, okay, is symmetrical here. So this area right here is going to be the exact same as this area. So what you could do is find the area of this part and simply multiply it by 2. Okay? That's probably the easiest way to do that because you know a lot about the sine graph already. The other thing you could do, which this is probably what you're going to have to do with some other questions that are similar to this, okay, is you're going to have to find out where this split is, and obviously this is splits right at 0, and so you could do two parts, right? You could do this part, area A. You could find area A using this as B value, the 0 is B value, and so on. And then you can subtract the area over here, area 2, which is going to be negative, right? So you're going to end up with a negative area. And that's what you could do knowing the situation, all right? And so then you'll get really double the area again like you did the first way, okay? Or you could simply find the area you know is positive, find the area that you know is negative, and then just flip this sign and add them, right? That's the same thing. So just really quickly, an example where you might want to do that, and we won't take the time to do it, but let's say we have a graph that looks something like this, okay? And I want you to find me the area between here and here, okay? So what you could do is do the antiderivative of wherever this crazy function is, find this area, which you know is going to be a positive area because it's above the x-axis and underneath the boundary curve. Then you could separately find this area right here, which is actually going to be, in actuality, the negative area, right? And so you know that's going to be a negative. You flip the sign over here, and then you add them. A1 plus A2, and you're good to go. Okay? Does that make sense? Okay? There's a few steps that are going to be involved, perhaps. Okay, you got to know these boundaries. Well, that one's 0. You got to figure out what this is. Maybe you don't know that. On this crazy function, you have to find then the 0 or the zeros with the graphing calculator, maybe, or right by just setting the equation equal to 0, finding out where the zeros are. So probably using a graphing calculator would be a good idea. But you're going to have to know this boundary in that case, because you can't assume that these are equal, right? Okay. Does that make sense? Question?